Hello everyone and welcome back to my channel. In this video we are going to study the concept of modules in Python. So let's get started. Now talking about the first question, what is a module? A module is a file containing Python definition and statements. Python definition and statements are the instructions written in Python. Or more precisely, a module can define functions, classes, and variables inside it. Suppose if I write multiple functions in a Python file, I can term it as a module of having related functions. We use modules to break down the large programs into smaller, manageable, and organized files. Grouping related code into modules make the code easier to understand and reuse. A module can include the runnable code in it. Now let us first understand how many types of modules are available in Python. So here module can be divided into three broad categories. The first one is the standard modules or the inbuilt modules. That is, these modules are already built in with the Python interpreter. The second is the user-defined module, which is we are going to demonstrate in this very video. These are the modules that are created by the users according to their requirements. And the third one is the third-party modules, that is users like us who has created certain functions and definitions which are really useful. So what they did is they actually club them into a module and then make it freely available for reuse to the other users available in the community of Python, right? So first of all, let us see them one by one, and then we will be moving to the programmatic demonstration. So the first module is the standard modules. Python comes with the library of a standard modules described in a separate document, which is known as the Python library reference. Python's standard library is very extensive, offering a wide range of functionalities. For example, sys module, OS module, statistics module, math module, random module, and a lot many. We will be having a separate video on each of these modules, right? But here I shall be demonstrating you a little bit of them, that how we can actually import them and use them in our Python files, right? The next one is our user-defined modules. Now the user-defined modules is written by the user at the time of program writing. Now to create a module, just write a Python file and save it with .py extension, and then access the module with the help of the import statement. Now in order to include a module into your current session or into your current code, you have to import that module inside your Python file, right? So let us have a demonstration of a user-defined module with the help of an example. And for that, we have to move to our Visual Studio Code. So here, now I am on my Python screen, and first of all, we are going to look at the inbuilt modules that are present, or the standard modules first. So standard modules. This is the first category of module that we have. And here, for example, I'm going to demonstrate how to include a module inside your Python file, right? So the keyword that you're going to type over here is import, and here I am importing a math module, right? So what is math module? It is a inbuilt module that is present in the interpreter or present with the interpreter of Python. And when we install Python, this math module comes, as it is. We do not have to write anything but this particular statement, that is import math, and with this we are going to actually access or work upon each and every method that is written inside this module, right? So in order to actually visualize that what all things are actually written inside this module, we can make help of this directory function, and with this, if I run the code, then it is going to return a list of all the functions that are present in the math module. Right. So now on your screen, you can see that it returned a list and with a lot of functions written in it, like sqrt, like the trigonometric function like tan, cos and sine, like power function, the value of pi, the permutation and combination, right? The absolute value, the factorial, the floor and so on. So these are the functions which are actually written inside the math module. And in order to use these function, because it's an inbuilt function, so we can use it directly. Let me just make use of, let's say, math dot factorial. In order to use this function, which is factorial, it is written inside the math module, right? So we need to use this dot operator, like we need to tell Python that I want to calculate or I want to run or call this factorial function on the variable, let's say 5, but we need to tell the Python that it is present inside the math module, right? So the syntax of writing is math.factorial, and if I run the code, you can see that 120 is printed on your screens, right? So you didn't have to write the complete code of factorial, but the program is made so easy by just using that inbuilt function by calling the math module. So that was a simple example of telling you that how we can actually import the standard modules which are already present in our, that Python library, right? But in this video, we are going to focus on how we can actually write our own modules, right? So, and about these standard modules, I will be making separate videos in detail of about the math module, the sys module, and random module and all, right? So let me just delete it and write the user defined modules, right? And let me see how we can actually work upon it. So for this, what I'm going to do is I will be creating a file. Let me just create a new file over here, right? So I'm creating a new file and the name of that file will be areas.py, right? So this is a Python file and I will be creating a new file, and let me just save and close this. Now, what I'm going to do is this particular module will be calculating areas of different shapes, right? So what I'm going to do is, now, in order to understand module, because now you will be able to understand what is a module exactly, it is a combination of different types of functions, classes and variables. So here let me make a simple module which is a collection of functions, right? Which is calculating area. So here I am defining my first function which is known as area of a rectangle, right? So let me just call it as rect, right? So area of a rectangle, and it will be taking two parameters, which is your width and the height, right? And what is going to return? It is going to return W multiplied by H, right? And with this what I'm going to do is I will be also writing a doc string in order to explain this particular rect method or rect function, right? So this calculates the area of a rectangle, full stop, right? So this is my first function inside this areas.py file. Now my second function, which is calculating the area of a circle, let's say, right? And this is going to take one parameter as the radius, and what it's going to do, it is going to return the value of let me just do one thing. Let me just uh, the value of pi, let's say 3.14 multiplied by r power 2, right? Now this is another function, and what it is going to do, this is going to calculate the area of a circle, right? One more function let me make over here, which is calculating, let's say, the area of a triangle. So let me define as area tri, and this is going to take the sides, that is ABC, three sides of a triangle. Now the doc string, which is this calculate the area of a triangle, and one more. There you go. And for that, what I will be doing, I will be calculating A plus B plus C divided by 2. Now that is nothing but the hero's formula for calculating the area of a triangle. Return, and the value which we are going to return is the formula for your area multiplied by S minus C and whole multiplied by 0.5, right? Because we need square root, right? So this is nothing but this is a file which is having the different functions called the areas, right? Now what I'm going to do is I will be going to a new file which is this of my user defined modules, and what I'm going to do over here is I am going to import areas, right, as a module name. So right, and now what I'm going to do is import areas. Now areas is my .py file in which I have made all those definitions, right? And what I'm going to do over here in a different Python file, I am importing areas as I was importing math. Math was the standard function, so I didn't have to write all those functions. But area is a user-defined function which actually I made. Right. So now what I'm going to do is I'm going to make a print statement, the area of rectangle is, and what I'm going to do is I will be calling my function which I made in areas using areas dot ar underscore rect, and here I need to pass two parameters, let's say 5, let's say 8. So this will be the area of my rectangle. Now what I'm going to do is copy the statement again here, and this time I will be calling the area of a circle, and in place of rect I need to type circle, right? And only one parameter is required, let's say 2, which is the radii. And next what I'm going to do is to calculate the area of a triangle, and this time in place of rect I will be writing tri, and I will be giving the three sides as this, right? So now what should I expect? If I run this code, I should get the answers for all these things calculated by the functions which were defined in import areas, right? And the way of calling is just same as we were calling the functions written in the standard module, right? So if I run the code, then you can see that all the functions are working pretty much fine. Now, the importance is that because that particular function are already written inside the module, I didn't have to write those functions again. I just imported the module and used them as it is. So that was how we can actually work with, the user-defined modules. Next thing which I want to tell you guys is something about aliasing, right? So what we can do is we can do module aliasing. Now what it is, sometimes it is difficult to write every single time area dot something, right? So suppose that the name of the module is very big, right? Here it is a smaller name, but let it's a big name. So as A. So what I did, I imported areas as A. So anywhere where I will be referring areas, in place of writing the complete name areas, I will be using the aliased name, which is A. And now if I run the code, you can see that the code is working as it is, right? We got the same output. So what this is actually helping us to reduce the size of the code, right? So you can import module as a small alias name. So the next thing is using the from and import keyword together. What if I do not want to calculate all the areas, right? I have three functions which are calculating the area of a rectangle, circle and a triangle. What if I want to work only with circle? So is it feasible to import each and everything out of my module into my program and making it bulky internally? No, what we can do is to make use of from keyword. So what I want to take from areas, right? I only want to import area underscore circle, right? Now what I want to do is to just print the area of my circle whose radius is 2. Let me just run the code and you can see that 12.6 is working perfectly very fine and we got the answer. What if now if I want to calculate the area of the rectangle? Let us check this too. Let us take the values as 4 and 5. And if I run the code now, there is an error because we haven't imported anything else from areas except areas circle. Aliasing of these functions as, let's say, C. Now what I did, I imported circle area from this as C. So in place of this particular bigger name, what I can do is make use of C only, right? So that is nothing but the aliased name. So if I run the code, you can see that now 12.56 is working very fine. So this is how we can actually make aliasing with the imported functionality only. So we didn't have to actually use it every single time AR underscore circle. We can replace that name by the alias name, which is C. Now, so that was a very small lecture on what is a user defined module. And what else we can do with this is, suppose we are actually importing, let's say, from areas. No, let me just import it completely. So if I do import areas, and if I want to print the functionalities which are available in this particular module, I can very well make use of the dir function on my user defined functions as well. Right, so you can see that the content is the area circle, the area of rectangle and area of triangle, right? So these are the contents which I have written inside my user defined module, so that we can also visualize with the help of the dir function. Now, the third type of module that we are going to study is the third-party module. A third-party module is any code that has been written by a third party. That is neither you, that is the programmer, or nor the Python writers, right? So, the user-defined code is written by you, and the standard modules are written by the Python writers. You can use them to add functionality to your code without having to write it yourself. And to use them, you have to install them first. And in order to install them, you can make use of the pip command or the pip module. The examples of such third-party modules are pandas or numpy or scikit-learn and so on, right? So that is how we can actually work with our third-party module. So let us now go back to our Python screen and see how we can install and work on the third-party modules. So here, in order to install the third-party module, what I'm going to do over here is I will be making use of the pip command using install, that is pip install. This is the command with which you can actually install the third-party module and the name of the third-party module that you want. So pip is something with which we can actually install something. So pip space install space the name of the third party module that you want to install. Here I am installing pandas. So you can see that the bars are started filling and it is installing all the dependencies as well as pandas for my Python. So here the third-party library pandas is now being installed on our Python 3.9. Right. So now we can make use of it. And in order to demonstrate it, what I'm going to do is I will be creating a file over here. Let's say the name of the file be temperature.csv. We can make use of the pandas that that we can actually manipulate on the .csv file, that is comma separated values file. I will be making certain comma separated value which says temperature 1 comma temperature 2, and here I will be having those value, let's say 23.4 comma, let's say 56, let's say 25 comma 9, let's say 44 comma 44.7. These will be different values of the temperatures, right? And then let it be 34.7, let it be 24.7, then comma, let it be 36.9, right? So these are now, after creating this file, the CSV, that is comma separated values file, I'm going to write a code where I'm going to actually make use of this third party module. So I'm going to import pandas, right? And here I will be making use of this file. So I will be opening with open the file name, and because I'm using this temp file, so I will be going to here, right clicking it, and then just copy the path of this file, and inside the quotes I'm going to paste that particular path. And remember that we need to change the slashes because this is not going to be get recognized. So the slash should always get inverted like this and like this file, and here I'm going to use it as F and enter. Now the next thing is what I'm going to do is that data is equal to pandas, because we need to refer the module name first, dot read underscore csv, and inside that I'm going to pass F, and just a simple code, I'm going to the print the data. And now if I am going to run this code, right, if I'm just going to run this code, you can see that the particular data is now been actually on your screen in a in a defined pattern, right? So the file was this comma separated value, so it's represented it in a structured manner, right? It was unstructured and now it is structured. But here we are not going to get into the details of the module pandas. It can do a lot of things, but here it was a little introduction of how we can actually install and use the third party modules. So that was an introductory lecture on modules, and I hope that you enjoyed it and learned something through it. And if you want to learn more about Python, then stay tuned to my channel. Thank you.